So the last thing that we need to take a look at today, and kind of the last piece of our puzzle of graphing these polynomials, breaking them down completely, is this topic of multiplicity. Now you'll remember that we've looked earlier in this unit at things such as degree and leading coefficient to help us kind of picture the directions of the graph. Multiplicity allows us to picture what happens at those zeros. And so as you look at this first set of 4 graphs here, I want you to take a minute and notice what is happening at the zeros. What are the options? So in problem A, you'll see a 0 here at -2, and then one at +2. Right, you'll see in B, there's a 0 at -2, and there's a 0 at 1. Part C, you'll see a 0 at -2 and a 0 at 1. And then in this last one, you'll see a 0 at, again, -2 and 1. And so they all have the same zeros, and yet these zeros look very different. What is happening at the zeros looks very different. And you'll notice there's a few options. Of it might go through that 0. It might kind of touch it and then go away from it. And this is what we're going to look at today with this idea of multiplicity. So make sure you're getting down some notes on this. This is going to be really important as we move forward to putting things together. So when the multiplicity of a 0 is odd, the function, oh, I don't want this pen. The function crosses the x-axis, so it will go right through it. So if our 0 was here at 1, it would go right through that 0. But if the multiplicity of a 0 is even, the graph has a turning point at the x-axis. And I've in the past even referred to this kind of as a bounce. So if here's our 0, it might come here and touch it and then go back up in the other direction. Okay, and so we can look at that multiplicity by looking at, you'll see that this is broken down by zeros, right? This one has multiplicity of 4. If there's nothing there, remember there's a 1. So what that means is that at this 0, when x is equal to 0, it's an odd multiplicity, which means it's going to cross. Here at this 0, there's a 0 at x is equal to -4. And again, it's that exponent of 1, which means it's an odd multiplicity. It's going to cross my x-axis. And here's another 0. When x is equal to 1, notice it has an exponent of 4. It's an even multiplicity, which means it's going to have a turning point. Or what maybe is easier to think of as it's going to kind of bounce off of that 0. Okay, so this is how we use multiplicity, allowing us to take a look at what's happening at that 0. Let's look at one more. Again, here's our exponents. If there's not one there, remember that it's a 1. Okay, so here when x is equal to a -2, we have an even multiplicity, which means it's going to have that turning point. It's going to touch -2 and then go back in the other direction. Here, when x is equal to 1, it has an odd multiplicity, so it's going to cross my x-axis. Now notice what's happening here. This one we are going to need to use our quadratic. We don't have a specific 0 here. Okay, so if we use that quadratic formula to find our 0, what would it mean? I want you to go ahead and find that. Well, what's going to happen here? Okay, so these are kind of our things that could happen. Now, this will only happen at our real zeros. Okay, so when you get to this one right here, you're going to actually find out that when we put this in our quadratic formula, we can find our imaginary zeros. And there's going to be one positive imaginary, one negative imaginary. But it's not actually going to have a cross or a turning point because these are imaginary answers. So any of our real zeros, we can know what is happening at that x-axis. So let's look at some problems with this. So here, the first thing, excuse me, you'll notice is that our function is broken down already. It's already factored. This is really important in order for us to see those zeros. Again, we want to pay attention to our multiplicity. So here we have these ones on all of them, which means x equals 0 has that multiplicity of 1. Oh, wait, this is us finding the zeros. So x is equal to 0, right? We did this in the last page. We have a factor that looks like this, which means x is equal to 4. Right? We need to find those specific zeros. Those are the points that we're going to pay attention to. So I've just drawn this little chart here to help you kind of organize what's going to happen. 0 has a multiplicity of 1. I like to write these right on that line so I remember what it was, and it's going to cross. Each one of these is an odd multiplicity, so they're all going to just cross right over. So in order to have us be able to sketch this, what I want you to do is we're going to start by marking those zeros. We know that our graph is going to cross in these locations. Now, the next really important thing is we need to go back and think about that table that we talked as we started this unit dealing with end behavior. Remember that we could have either an even or an odd degree. We could have a positive or negative leading coefficient. And you had a chart that looked like this. So what we need to do is we need to figure out what our end behavior is and allow that to help us sketch the middle of our graph. So if we had to figure out if this is even or odd, well, this is a degree of 3, right? There's 3, 1, 2, 3. And our leading coefficient, look at what's going to happen when we multiply these numbers together. Our leading coefficient is going to be 1. So if our degree is odd and our leading coefficient is positive, we're going to have a graph that looks like this on the end, right? It's going to be down and up. So now what we're going to do is we're just going to kind of continue that graph. This is just a sketch, right? So it doesn't matter how high it goes. We want to see right now that you have that end behavior. Here's our end directions. And we want to see that it's going through these points with the right type of multiplicity. This will give us a general shape of what our graph looks like. Okay, let's look at another one. So the first thing we need to do is start by factoring this. Now, this might take you longer to factor. You might be able to see the factors. You've got division tools. You've got quadratic formula tools. We need to kind of put it all together. So I'm going to start by taking out this x. I can factor out a common factor first. I notice that I can still even take out a 4, right? So I'll have 4x. And then when I get here, I notice that I can even just factor this. Now you might go in and work that quadratic equation. I can see that I'm going to factor this completely into these different parts, which means I'm going to have 4x equals 0, x plus 3 equals 0, and x minus 2 equals 0. So I factor them. I know that in this case, my 0 is 0. I have a 0 of -3, and I have a 0 of a +2. So I need to figure out what this graph is going to look like. These all have a multiplicity of 1, which means that each one of these is going to cross our graph. So let's start by marking these here on our graph. We have a 0, 2, and a -3. This has a positive leading coefficient and an odd degree, right? We look right here for that information. That's going to tell us our end behavior, which means our end behavior again is going to be in this direction. So I'm going to start down here at the bottom. Again, remember that these, how tall these go, exactly what happens in between those x intercepts doesn't matter to us as much right now. We want to get that general shape. So you'll see my end behavior, and you'll see it crosses through each one of these zeros with the right type of multiplicity. Okay, I want you to take a look at this last one. Now, again, we need to start by factoring this one. If you get to it in the video, awesome. If you get a little stuck on this one, just skip it. This is an extra one just to kind of show you some more practice. So I'm going to start by factoring this. And I know that this here is that pattern difference of squares. So I'm going to get x squared minus 9 times x squared plus 9. Okay, then this part right here is another difference of squares. So I'm going to have x minus 3 and x plus 3. This is going to give me, I can't factor this anymore. It's going to actually give me imaginary zeros. Okay, which means it's going to have another, it's going to have kind of a shape like this in off of the axis. That 0 is going to happen somewhere besides the x-axis. So I'm going to have x minus 3 is a 0, x plus 3 is a 0. Technically, x squared plus 9 is also 0. So we have one at 3, we have one at -3, and we have this imaginary one. Okay, so at 3, at -3, you know that this is going to cross. It just has a multiplicity of 1. So will this. So I mark those on here. Okay, so we're going to think of our end behavior. We see here that we have a positive and an even. So our end behavior is going to look like this. So we know we need to start up in this direction. I'm just going to have this little kind of, right? It's not going to go all the way down. I have another little kind of shape in here, but remember, we are most concerned with seeing these end behaviors and these real zeros marked.